Hello friends, welcome to my YouTube channel Manoj Networker. So today I'll talk about what is a load balancer and why is needed and why it is very important. So as the name itself says, LB means load balancer. So it will balance the load. So basically, before learning why how the advantages of load balancer, let's see about the workloads in the real-time environments. So we have two kinds of workloads. So one is static workload, one is dynamic workload. So static workload can be predicted, but dynamic workload will be unable to predict. We don't know how many number of users will access our application. So to understand even better, so I have just come up with one example. So like let's say this is my application server that is running in TCS company. So the website name is, for example, tcshr.com. So the name itself says, so this application will be used by the HR department to see the onboarding formalities and to see the exit formalities, just for example. So the website name is tcshr.com. So consider TCS has 5 HRs and they have 5 computers or 5 laptops, and they can all go on access that application and no problem, because this is a static workload and the users can be predicted. So in this case the users count will be 5. Like let's say if tomorrow some other user will join, it's okay. So this server can handle one or two users extra also. So this kind of setup is called as an static workload, where the workloads are already predefined. So like let's see the application of Book My Show. So this is one of the famous ticketing film ticket booking thing, Book My Show. So here the workloads will be unable to predict. We don't know when the users will be more and when the users will be less. Like let's say one plain day, one normal ticketing day, like let's say 100 users is using this application and booking the tickets and all. Whereas like let's say this Book My Show announced one pop singer is going for a live on so and so date, so and so time, and the tickets are available. Then almost like let's say 10,000 users will try to come to this application and they will try to book the tickets. So the first come first serve basis. Now if you see, these are a unpredicted user surge. So one day the users are going 100, the next day users are going to 200, the next day the users are going for 10,000. If you see the statistics, the Book My Show application is working like this. So this is called as a dynamic workload, where we will not be able to predict the number of users. So what we can do for this kind of thing means, we can add one load balancer so that it will equally distribute the load. Even though now for 10,000 users are coming, the load balancer will ensure that the load is equally distributed between all the servers. It could be 2 servers or it could be 3 servers in the backend, and it will ensure that all the 10,000 users are getting the tickets. Now let's see the further discussions in related to load balancer. So let's jump on to the today's session. So basically, a load balancer is a device or service that distributes user traffic across multiple servers or applications to optimize the performance, efficiency, and capacity. So it works by acting an invisible facilitator between the user and the server group, so ensuring that all the servers are used equally. So a load balancer also enables distribution of network traffic dynamically across all the resources to support an single application. So like let's say if you have 3 servers that are running one application, and so the load balancer will ensure all the 3 servers are getting the load distributed equally among each other. So load balancer ensuring so no single server bears too much of demand and eventually spreading the load. So if you have 3 servers or 4 servers in a pool, so all the 4 servers or 3 servers will get the equal load balancing and the share. So so that it improves the responsiveness and availability of the applications or websites for the end users. So load balancers can be deployed as a software and hardware model, and they can help you to reduce the performance issues, because by spreading the load across the multiple instances, load balancers can reduce the risk of applications experiencing performance issues. So as I said, if you have only one server and one application is running in that, so maybe if like let's say 100 users are trying to access to that particular server, so they may get some sort of latency or they may experience some sort of performance issues. So to solve all these kind of problems, So we can put one load balancer in front of your application servers. So in that case you can have two servers, or you can have three application servers like this. And you can put one FI load balancer. So FI is one of the vendor who will manufacture the load balancers. So now all the three servers are application servers, and you can put one load balancer. So the customer sitting from here, they can access the services using F5, and this F5 will ensure that the load is going to all the servers equally and eventually, and manage the HTTP requests. So load balancers are often used to manage HTTP requests for sites with large audience that need to handle many requests per second. So like let's say you take any e-commerce website or any ticketing websites where multiple users are accessing their web server and they are accessing the services. So it needs so much of processing capabilities, so that if you add one load balancer before the servers, so that this load balancer will ensure that the data are going to all the servers eventually at a time. So it will also ensure the reliability and availability of your servers and the monitors. So you can see one pictorial representation of how load balancer will work. So these are my end user clients, and these are my servers sitting somewhere in my office. And if you see, the users are coming from the internet, and first they will hit all the user traffic to the load balancer, and now the load balancer will decide where to send the data. So all these you can consider as an application servers or any kind of DB servers. So here in the load balancer we can put some sort of loading mechanisms, like let's say source hash or round robin or least connection. We can choose whatever the mode we want to run, so that the load balancer will ensure so everybody is getting the equal traffic. So, and why load balancer is needed? Because modern applications and websites cannot function without the load balancing mechanisms on them. So this is the reason such applications and sites serve millions of simultaneous requests from end users at a time, and returning the correct text and images or related data whatever the user is asking for. So adding more servers was a good idea, but for to manage that high volumes so far. But the concept of balancing the load with a dedicated load balancer unit is a much more economical and effective way of ensuring the peak performance. This is very important. So your load balancer will ensure the availability of your resources at the peak performance of your website or application, and offering the end user a great level of experience. And if you can see the models, so a load balancer can come up with software or hardware models that distributes the connections from clients to set of servers, and you can eventually run the load balancer in any of the cloud environments also. And types of load balancers. So before moving that, let's see the advantages of a load balancer. As I said, it will help you in ensuring the application scalability. So like let's say for example, we have the big billion days sale, is live from Flipkart or Amazon. So what will happen? So a normal day we have let's say 1,000 users will access the Flipkart and 1,000 users will access the Amazon.com. But at the time of this sale, at a time 10,000 users traffic can come to their application. So now their application servers should ready to process all the 10,000 users data at a time. So that's why these are called as a dynamic workloads. So one day the load is less, the other day load is more. So if you add a load balancer, so your load balancer will ensure the application scalability is there, so that it can serve all the 10,000 users in this case. So imagine if you are running a ticketing company. So in this case Book My Show, let's say one pop star, for example anybody, so the tickets are live in the Book My Show. So at a time it will experience a huge data surge from the users, because they want to buy the tickets. So within 5 minutes or 10 minutes everybody will log into their portals, and to ensure the data is processing efficiently, so they need one load balancer. Or the one more example is let's say flight ticketing apps. So if you have any holiday season, or if the flight companies announce any kind of sale, so many people will go to the flight ticketing apps and they will try to book the tickets on hotels, let's say Make My Trip and Go Ibibo, etc. So there also they they will experience sudden user surge in their applications, and these are called as a dynamic workloads, and they will see big spike in their traffic by having the load balancer to request the clients and traffic to the available compute surfaces, and that means more customers can get their desired tickets, and end of the day the customers will be satisfied with so and so application and its availability. And as I said, application availability, so even if you see here, like let's say I have created one small topology. So here I have my computer one, we have the F5 big IP load balancer is available, and we have three servers that are running. So if any one of the server and all servers are running some application, so all these are, you can consider app servers for images. So all those servers will retrieve some sort of images. So like let's say if this server one is went down at any given point of time, this F5 will understood, and now it will send the request to server 2, and it will send the request to only server 3, because this S1 is down. So it will ensure that no requests are forwarding to this particular server. So that kind of mechanisms your load balancer can do, ensuring your application availability and application security. So it can also provide some sort of security. All the load balancers nowadays in the markets, they can provide some basic sort of security, like it will provide extra layer authentication for DDoS attacks, and they will reroute the traffic to the best possible available server. So they will help you to provide inline layer of security to some extent. And application performance, of course, by doing all of these above, a load balancer boost the application performance by increasing security, by optimizing the uptime, and by enabling scalability through spikes in demand. Load balancer keep your applications working as designed and the way you want to be, and your customers, they want them to. So I hope this is clear, the advantages of a load balancer. Moving further, different types of load balancers. So actually we have layer 4 load balancers and layer 7 load balancers. So they are also incorporated in OSI model of the framework. So I have talked about OSI in other video. So I'll add the add card here. So if any of you wanted to go to the OSI model, I suggest you to go and watch the OSI model. So basically load balancers will operate at layer 4 and layer 7. So layer 7 load balancers, basically they will divert the traffic based on the data from network and transport layers only. So here they will be mainly looking about IP, TCP, FTP and UDP. So here in this layer 4 load balancers, the load balancer IP address is the one that is going to advertise to clients for a given website. So once the load balancer received the correct traffic from the client, so when the load balancer gets the request, so it's changed the recorded destination IP address to that content server, and it has chosen, so that the traffic will be forwarded to that correct server. So whereas layer 7 load balancers on the other hand distributes the request based on the data found in application layer. So this is the top layer of your OSI model, application layer. So this layer 7 load balancers has the capability to do the rerouting of the servers based on the HTTP headers, cookies and the HTML form data. So they can also do the content switching is also possible with the help of layer 7 load balancers. And we have seen the advantages of that one, and additional benefits if I talk about. So automatically detect the server failures and redirect the client traffic. So this is the best example. So automatically it will detect the S1 server is down, and it will ensure the traffic is passing on to server 2 and server 3, and allow for server maintenance without any impact. So in real time we will be applying the patches to all the servers. So this is an maybe Windows server, this is the Linux server, or this is a Windows server. So any server in that case. So normally in real time we will be applying the patches. So like let's say even today if you would like to apply the patches for S2, there will not be any impact because S1 is available, S3 is also available. So it will ensure my services are running all the time. So provide automated disaster recovery to do the backup sites, and add or remove application servers without disruption. So like let's say if anything gone faulty, or if you wanted to remove any server, or if you wanted to add back any server to the pool, all those things are possible, and the end users will not experience any down issues. and monitor and block the malicious content also. And we have application level load balancer also. So if you see this diagram, you will get some idea about what is an application level load balancer. So if you see, we have the end user computer accessing some resources related to images or API or data. So the traffic will hit to application load balancer, and you can see the EC2 instance is nothing but our application servers are running in the Amazon cloud. So this application load balancer will ensure, like let's say if this computer is asking for images, all the traffic will be diverted to this particular application server. So if he is asking something related to data, so all the traffic from end user will go and divert to the application server 3. So if he is asking anything related to API, so all the traffic will go and hit to the application 2. So these kind of things we can do in the application level load balancing and is live in the production. So we can do these kind of changes in the production environments. And health monitors, so this is very important. So any load balancer basically, so always they will look for the health monitors of their servers. So load balancer detects the health of a backend resource and only send the traffic to servers that are not able to satisfy requests. So as I said, so here this VIP always actively monitoring the pool traffic. So this, like F5 will see the statistics of S1, S2 and S3. So as I said, if any of the person is unhealthy, so if the healthy parameters are unable to match, so now this F5 will ensure it will not send any request to S3 and it will only send the request to S1 and S2. For example, like let's say after some time this S3 also came up, then automatically again the health monitors will identify that the S3 server is live now. So again, now if any new request is coming from the client, so since S1 and S2 is already occupied and they are working, all the traffic can be diverted to S3. So if anything is down, automatically it can reroute the traffic. So if any server is coming up, so that mechanism also there, so it will identify and it will automatically detect that server is available now and it should divert the traffic. So this is just an introduction of load balancer, and we have so many vendors also in load balancer. So F5 is one of the predominant load balancer vendor. So I hope the session is informative. So if you need any information on load balancing, please do comment so that I'll help you. Thanks.